Bismillahirrahmanirrahim. Assalamualaikum. In this video, we will see the implementation of instruction OR and exclusive OR and MVNS. Here we use instruction ORRS, here ANDS, here MVNS, and here EORS, exclusive OR. Okay, in this example, I assume that port A is connected to address 2000.0.0.0, port B address 2000.0.0.0.4, port C 8, port D C, and port E 2000.0.0.1.0. Okay, first thing first, in solving this problem, it is better for us to come out with our Boolean equation. This one we call the Boolean schematic. From this Boolean schematic, we transfer to Boolean expression. First, OR. Port A, we OR with port B. Here, port A, we logical OR with port B. Sorry, it's not port B. With port B. And then, port C, we logical AND with port D. Next, we invert this port C and port D. And after that, and last, we do the exclusive OR between these two output. So, next step, we better mark which process that we want to execute first. In my case, I prefer to use this one. My first step will be to do the OR process, not addition, OR. Second step, I'll use AND, ANDS. Third step, I will invert this AND. Step, and fourth step, I do the exclusive OR. And the final step, I'll copy all the result to port E, or I will send the result to port E. Okay? Okay, after we finish with our Boolean equation, we can start develop our flowchart. Remember, flowchart must start with start and initialization and close with end. So, and next we can arrange all the process that we discussed earlier. This one will be the first process. This one is first process, second process, this one's the third process, fourth, and last process. Okay, start initialization. Port A, here we logical OR with port B. Logical OR, not add. Second step, port C, we logical AND with port D, and the result will be stored at R3. Third step, we negate R3, yeah, and last we exclusive OR the result from this OR gate with the result from this inverter here, and lastly we send this the result here to port E at address 2000.0.0.1.0. We close with AND. After we finish with our flowchart, we can translate this every chart to assembly coding. Start with N3. Start with N3 for start part. For initialization, here, for initialization, I transfer data to each particular register. R1 data for port A, port B I transfer to R2, port C I read data and send to R3. For port D, I read data from port D and I send to R4. This time I use indirect with offset addressing mode. I just use one register to hold base address. Here, if we look here, the base address for all port is at 2000, 000, 2000, 2000, 2000, 2000, and 2000. I only use one register to hold the base address, and next I use offset, indirect with offset. Second register, port B, offset 4 byte from base address. Port C, offset 8 address from base address. Port D, offset 12 address from base address, and port E, offset 16 byte from base address. So after I finish transfer all this, all the data to the register, I continue with OR operation, ORRS, between the register R1 and R2, and the result store at R1. Next, and R3 and R4, and the result store at R3. Okay. I use instruction move negate to not register R3 and store also at register R3, exclusive OR R1 and R3, here R1 and R3, and last I store result from R3 to port E. Use offset hexa 10 equivalent to 16, and I close with N. After that, we can copy all this coding, yeah, to kill. Here are the coding, starting from here until here. Okay, exactly the same coding, yeah. I copy to kill, and then this part I only write this coding to send my dummy data to memory so that we can run our simulator. This is my dummy data, or you can change the data, any data that you like. So as usual, we need to build our file to make sure our coding is free from error, and then we run the debug process. Okay, so I just load my dummy data to memory. Okay, you can see here now data is ready in memory, starting from address 2000. Okay, first let's start our coding. Yeah, starting first line our coding, I load data for port A, port B, port C, and port D to each register that I allocate for them. Okay, now we're ready to do the logical OR. Yeah, OR between port A and port B. The value for port A store in R1, and value for port B store inside R2 here, R1 and R2. So the result will be updated at R1 here. So 5, 6, 7, 8 will be all with 1, 2, 3, 4 here. 5, 6, 7, 8 all with 1, 2, 3, 4. Here is 5, 6, 7, 8. And then here's 1, 1, 2. Oh, this is not 2. 1, 8, 2, 1, 2, 3, 4. No. 1, 2, 3, 4. Okay. 1, 2, 3, 4, 5, 6, 7, 8. R1, R2, R1, R2, R1, 5, 6, 7, 8. Okay. 5, 6, 7, 8. 1, 2, 3, 4. So, all result, meaning that either one register logic 1, our result will be 1, like this. 1, 1, 1, 1, 1, 1, 1, 1, 0, 0. And here is equivalent to 5, 6, 7. Here is C. 5, 6, 7, C. Okay, let's run our simulator. 1, 2, 3, 5, 6, 7, C. This one is for OR. Next operation is AND. AND between R2, R3 and R4. R3 7, 8, 5, 6, 3, 4, 1, 2. 7, 8, 5, 6, 3, 4, 1, 2. R4 is 3, 4, 1, 2. We AND. Let's see the results. Remember, for for logical AND, result is only 1 when both register logic 1. 1, 1, 1, and 1. So final result will be 3, 0, 1, 2. 3, 0, 1, 2. 3, 0, 1, 2. Let's run our simulator. 3, 0, 1, 2. Next, move and negate result from R3. Where's R3? Here. Remember, move negate. We negate each bit. 1, 1, 1, 1, 1, 1, 1, 0, 1, 1, 0, 1. Remember, 0 will become 1 and 1 will become 0. And this result will be updated at register R3. New value inside register R3 will be here. C, F, E, D. C, F, E, D. C, F, E, D. Okay, let's run our simulator. 1, 2, 3. C, F, E, D. Please ignore the higher byte, higher 2 byte. C, F, E, D. And next, C, F, E, D here. We will do the exclusive OR. Exclusive OR between this R1 and R3. Here. R1 and R3 we do the exclusive OR. So copy this data. It's a template. Ctrl C. Okay, this is the data that we will do the exclusive OR between R1 and R3. No, this is the data for R1. This is the data for R3. We will do the exclusive OR. R3. Okay, like this. So this is the truth table for XOR gate or exclusive OR gate. Exclusive OR gate will produce result 1 if both logic. No, it will produce result 0 if both logic same logic. Either both are 0 or both are 1. Okay, it will produce 0. The rest, if both logic is not the same, so it will produce logic 1. So this is the result. Side R1. If both 0 or both 1, it will produce 0. 1. If not, result is not same, like this. 1, 1, 1, 1, 1, 1, 1. Okay? This one is 0 and 1. 0 XOR with 1 will produce 1 according to this table. 1 XOR with 1 will produce 0 according to this table. 0 XOR with 0 is also produce 0. Okay, so the result will be 9, 9, 9, 1. 9, 9, 9, 1. Okay. EORS. Okay, 991. Let's run our simulator. 1, 2, 3. Here, 9, 9, 9, 1. This is our final result. Wait, it's our final results. Where's our here? This is our final result here. So we finish this step, and we'll go to our final step to copy result to port C. No, not port C. Port E. To port E. Port E is located at address 2010. 2010. So from base address 2000, we need to offset by 10. Let's go to our simulator. Okay, we store base address offset by 10. It will point to address 2000 plus 10. Here, 2000 offset 10. Here, 4, 1 half word. 1 half word. So in 3, 2, 1, here's the result. 9991. Yeah, 9991. So the question is why I use half word. I load half word and I store half word also. Because in our example, we assume that the size of data here, the size of data for port A is only 16-bit. Port B 16-bit, port C 16-bit, port D and port E as well are all 16-bit. On our previous semester, on our previous example, we assume that the size of the data is 32-bit. The question is, what if the size of data is only 8-bit? Can you answer this question? Yeah, just simply change from H to byte, from half word to only byte size. Okay guys, hopefully you understand. how to answer this kind of question on your examination. For me, in the process to transfer this what you call it, the Boolean circuit to coding, it's not mandatory for you to come out with this Boolean expression. But believe me, it will help you a lot by doing this. However, for a flowchart, it is mandatory for you to create flowchart. Why? Because to solve any problem, there is more than one way. Like mine, I used to solve this gate first, but maybe you will prefer to solve this gate first. Okay, here you solve here until here, and then next you go to here. Or for the other person, it prefer to solve here and followed by here and here. That's why the flowchart is mandatory for every programmer to guide him in the process of write the coding.